Good afternoon, everyone. In the last class, we were discussing about the connectionless transport layer protocol, that is UDP. UDP is the user datagram protocol. So, where we have discussed about the segment structure of the UDP and how to calculate the checksum. So, if the input has been given, uh, it is a 16-bit input. So how you're going to calculate a checksum? So with the help of the checksum, you are able to identify or detect the error. So error can be detected as well as corrected with the help of the checksum. So that is the thing that we have discussed in the last class about the UDP protocol. So why it is unreliable, even if it is unreliable. So in which type of applications the UDP protocol can be used, because it is a bare bone protocol and no frills protocol. So no need of extra connection establishment is required when you're going to use a UDP protocol, and then no congestion control, flow control, so like that. So that's how the UDP protocol is going to work. So we have seen the segment structure of the UDP protocol as well as how to calculate the checksum to detect the error as well as correct the error. Okay, so today we'll discuss about the topic, the principles of reliable data transfer. Okay, usually what do you mean by the reliable data transfer? See, if we consider there is some problem in the network, there is some problem in the network, one of the important thing is the reliable data transfer protocol. So it will be a fundamental important problem in the networking, that it will be one among the top 10 problems in the networking. So suppose if a data packet, whatever you're going to send from the sender side, it has to reach the destination. Suppose if any error occurs, so it indicates there is a reliable data transfer is not occurring between the source and the destination. So this is one of the reliable data transfer is one of the fundamental important problem in the networking. Okay. So today we'll discuss about the reliable data transfer protocol and then the different versions with respect to bit error, with respect to sequence number of the request you're going to send, and the sequence number for the acknowledgement we are going to receive, and the protocol where it is set to be error free. So depending upon these things, so it can be classified into different versions of reliable data transfer protocol, that is RDT 1.0, RDT 2.0, 2.1, 2.2, RDT 3.0. So RDT indicates the reliable data transfer. The reliable data transfer, it is one of the trivial or one of the important, fundamental important problem in case of networking. Only if you have a reliable channel, then only the packet can reach the destination safe. The packet can reach the destination safe without any corruption of the data bits or without any losing of the data packet, whatever you're going to send. So you need a protocol mechanism, so where that is done with the help of the reliable data transfer. Okay, so the main aim of this reliable data transfer, so here we need a protocol mechanism where even if there is a corruption of bits or if there is a loss of packets, even after that also we have to recover those packets. Okay, so here we know that TCP, it is a reliable protocol. So in order to make your communication reliable, so what we have to build a reliable protocol even if the unreliable protocol is existing in the network. For example, TCP is a reliable protocol where IP, that is the internet protocol, it is said to be like your UDP, it is said to be unreliable protocol. But since the TCP is built upon the internet protocol, the IP protocol, it makes the communication reliable. Reliable in the sense recovering of the data. So without any loss or without any corruption of bits. Okay. So here, just you can look into this picture. Okay, so what it says, So it just says so how the communication is happening between the sender and the receiver. So here you can see the diagram. Here you can see the diagram. So usually for communication we need two entities. One is the sending process and the receiver process. So sending process is going to send the data to the receiver. Receiver is going to receive the data from the below layer. Sender is going to send the data from the above layer to the below layer, that is the upper layer to the lower layer, where it transmits through the reliable channel, so without any corruption or without any loss of packets, so they're reliable in the sense. And then so when it is received at the receiver side, the data will be moving from lower layer to the upper layer. So just this indicates the application layer as well as the transport layer. Okay, so now this is just providing the service. Next we'll see the part B of this picture. What it says, it is the service implementation. Okay, in the application layer, transport layer, so here in the transport layer we can see the reliable channel, but the physical medium, it may be unreliable, so it indicates the unreliable channel. Okay, so UDT and RDT, so what it indicates, just this picture actually represents the communication, and we are going to use some functions, okay, in order to send and receive the packet, or in order to deliver the data to the above layer. Okay, so like this we are going to see different functions in each and every version of the reliable data transfer. So what this RDT and UDT indicates, you can see this function. Okay, since it is an unreliable channel, whatever the packet you are going to send, so it usually it will be the unreliable data transfer send. See, this is the application layer. The application layer is blank here. Okay, this indicates it is an application layer. Now you can look into this picture at this part, where from the above layer, the with the help of the reliable data transfer, what it's going to do, it's going to send the data to the transport layer or the transport layer. Okay, so whatever the data it is going to receive, so since it is a reliable, so the data will be also reliable. So since from the transport layer protocol, it may be sending through the link layer protocol or the physical medium, okay, or the physical layer, means whatever the lower layers that exist. So in the lower layers, so this is said to be the unreliable data, means we can't say that this is going to be unreliable. Okay, in the link layer or in the physical layer, so whatever the data that you're going to send, we can't say that it is said to be reliable, because only if you use a TCP is reliable at the transport layer, but in below layers we can't say that it is said to be reliable since you are sending through the unreliable channel. So UDT send indicates send the data or send the packet through the unreliable channel. Okay, so now RDT RCB means receive the data from the lower layers. So after receiving, so reliable data transfer protocol, it is going to receive the data from the lower layer, that is from the physical through the unreliable channel. So this indicates the physical layer. So and here you'll be having the link layer and the network layer. So in the network layer, you'll be having the protocol called as IP. So that's why it is said to be unreliable. Now it is reached at the transport layer. Since it is a reliable TCP you're going to use, so that's why we are going to consider it as the reliable data transfer protocol receiver side. Okay, after receiving the data, what it's going to do, it's going to deliver the data to the application layer. It is going to deliver the data to the application layer. Okay, so all of you, so just notice that here you'll be having the application layer. From the application layer, so the data will be sent to the transport layer, and here you have the reliable data transfer protocol. So whatever the data you're going to receive at the transport layer, it is said to be reliable. But when it is moved to the down layers or lower layers, so it is said to be unreliable. So that's why UDT send. Now the packet you're going to send through this physical medium, that is physical layer, where unreliable channel is going to exist. Okay. So here at the receiver side, so through the reliable data transfer protocol, you're going to receive the data or the packet. Then it is moved to the transport layer. And at the transport layer, so it's going to extract the data, okay, and that data will be delivered to the application layer. So this is how the implementation will be done at the sender side as well as the receiver side. Okay, so we are going to discuss the principles of reliable data transfer. That is a general reliable data transfer protocol, how it works. Okay, and then RDT 1.0, RDT 2.0, 2.1, 2.3. So like that we have the different principles of reliable data transfer, or we can also call it as the different versions. Okay, so usually the characteristics of unreliable channel will determine the complexity of reliable data transfer protocol. Okay, so if it is an unreliable channel, so with through this unreliable channel, what it says is it shows how complex it is, how complex to achieve the reliability in the data transfer. So what are all the mechanisms that they have to include in the reliable data transfer protocol in order to make unreliable to reliable data transfer? Reliable data transfer protocol is one where we are going to apply some mechanisms. We need some mechanism to convert the unreliable channel data to the reliable data by using the checksum, or by sending a negative acknowledgement to the sender, indicating that you have to retransmit the data again. Okay, so characteristics of unreliable channel will determine the complexity of reliable data transfer protocol. So what are all the complexities that will be there in order to achieve the reliability while doing the data transfer? So what are all the mechanisms that you have to include in the reliable data transfer protocol to overcome the unreliability or loss of packets, or loss of packets, or corruption of packets? Okay, so I mentioned already. So important in application transport link layer, top 10 list of important networking topics. So what it says is, so reliable data transfer, it is one of the problem. So if we consider network issues, so one among the network issue will be always related to the reliable data transfer. Next, so here, so this is just the same. So whatever I have discussed before, the same, the repetition has been done. Okay, so just at the sender side, so RDT send and UDT send. So it indicates reliable data transfer send and unreliable data transfer send. So if it is in the transport layer, and if you're going to use a TCP protocol, then it is said to be RDT send. At the lower layers, we can't say that it is said to be reliable. So there may be chances of unreliability. That's why UDT send. While receiving at the receiver side, it is going to check everything and it's going to check the reliability. So that's why it is said to be RDT receive. And deliver data. So whenever the data you're going to move from the transport layer to the application layer, we are going to use a function called as the deliver data. Okay. So now RDT send, it is called from the above, pass a data delivered to the receiver upper layer. So usually this function will be called from above, means from the application layer. Okay, from the application layer, this function will be called and it will be delivered to the receiver upper layer. So with the help of the other layers that is present below it or beneath it. So through this, it is going to deliver the packet to the above layer. Okay, UDT send. So this is called by the RDT to transfer packet over unreliable channel to the receiver. So UDT send, I already said, so it is called by this RDT. RDT in the sense that is the transport layer protocol. So in order to transfer the packet through the unreliable channel, so UDT, since it is an unreliable channel, so we are going to use the function called as UDT send. Okay. And then RDT receive. So receive the packet that is going to arrive through the unreliable channel. Okay. So but you should see that suppose if there is any correction is required, if any error is existing, if there is any corruption of bits, then you have to send a negative acknowledgement indicating that you have to resend the packet. So that's why the reliable data transfer, it has to take care. And while sending to the transport layer, the packet should be error free. Okay, so and then So deliver data, this is the function call that will be called by the RDT to deliver the data to the upper layer. So these are the functions that will be executed by the reliable data transfer protocol generally. Okay, so now we'll see. So this reliable data transfer is represented with the help of the finite state machine. So usually what's this, what do you mean by finite state machine? Suppose if you, let us consider this is the state. If you give some input to the state, so after giving the input, so it will be moving to which state? So it will be, there will be transition from one state to another state, from state 1 to state 2. Okay, so if you give the some input, so what will be the output and to which state it has to move? If some event has been occurred, then what action has to be taken place? Okay, suppose if an event occurred, for example, if you open the tap, so what happens? You have done some event, you have opened the tap, so that is said to be event. So if you open the tap, then the water flow is nothing but the action that it's going to take place. Okay, in the same way the finite state machine is one where if you give some input, so some output will be generated. So due to that, so some action will be taken place where it is going to move from one place to another place, or from one state to another state, or it is going to move from one transition to another transition. Okay, so we all incrementally develop sender receiver sides of reliable data transfer. So initially only the communication with the help of RDT send, RDT receive, UDT send, deliver data. So that is the general communication that is going to happen. So we are going to add some events to the sender and the receiver so that we are upgrading our version in order to achieve the reliability among the communication, in order to achieve the reliability in the communication. So in order to achieve the reliability in the communication that is happening between the sender and the receiver, so we are going to adding, will be keep on adding the different versions, or will be keep on adding some events so that the reliability has to be achieved. At the end, the main aim is to achieve the reliability. Okay, so here whatever the communication that is taking place, it is said to be unidirectional. Okay, but the control info will flow on both the direction. Okay, but whatever the data transmission that takes place, so always the sender is the sender and the receiver is the always receiver. The sender has to send the data, receiver has to send the acknowledgement, receive the data and send the acknowledgement or negative acknowledgement. Okay, so here, since the data, it is said to be the unidirectional. Why we have taken unidirectional is, so for the better explanation. So in order to avoid the complexity, here we are considering the data transfer in the unidirectional. Okay, but the control flow of information between both the state, that is both the state in the sense sender and the receiver. So here it is said to be in both the direction. So in order to make understand very easily and what events is going to occur, and after occurring of the event what action is going to take place, so we are going to represent this type of communication with the help of the finite state machine. Finite state machine, the state finite means it is countable, where infinite means it's not countable. So it is accountable means whatever the states that you're going to represent is, so if you give some input it will go to the state that is known. Okay, so finite state machine, with the help of the finite state machine, depending on the event that it is going to occur, the action is going to take place, and after taking place of the action, so there will be transition from one state to another state, that is from sender to receiver, or receiver to sender, or sender to sender, or receiver to receiver, like that. Okay, so state 1, so when in the state, next state uniquely determined by the next event. So usually depending upon the event that is going to occur, so usually it will move to one or the other state. It depends on the action that it is taking place. See, here you can see a horizontal red line here. The content above the horizontal line indicates the event, that is event causing the state transition. And the Content below this horizontal line is, so what type of action that is taking place, actions taken on the state transition, that is event or the action. So content above the horizontal line indicates event causing the state transition, and content below the horizontal line indicates, so what action has to be performed or what action has been taken on the state transition. Okay, so this is how we are going to start. Okay. So now we'll discuss about the reliable data transfer 1.0. So here this 1.0, what it indicates is, so here there is a reliable data transfer over a reliable channel. The first principle what it says is, so here there is a reliable data transfer over a reliable channel. Means there is no any unreliability here. Here it is a reliable channel. Whatever the packet you are going to send, so it is going to reach the destination without changing the order. Okay, without any corruption, without any loss of packets. So this is the general or the first principle assumption that has been made. Means if there is a reliable data transfer over a reliable channel. Okay, so underlying channel perfectly reliable, there is no bit errors or there is no any loss of packets. Okay, and then separate finite state machine for sender and the receiver. Here you can see there is two finite state machine. Okay, so here this white circle whatever it is there, so this indicates the state. Okay, and here this arrow mark indicates flow to the next state or to the same state, and this horizontal, the content above the horizontal line indicates the event that is occurring, and the content below the horizontal line indicates, so what action will take place after occurring the event. Okay, so separate finite state machine for sender and the receiver will be maintained. So sender sends data into the underlying channel and receiver reads the data from the underlying channel. So sender always send the data, receiver always reads or receive the data. So here this arrow mark, dotted arrow mark indicates this is the starting of whatever in the finite state machine. So if you see the dotted lines with the arrow mark, this indicates this is the starting of the communication that is happening between the sender and the receiver. That is the starting state. Okay, so wait for call from above. So let us wait. Let us wait for the call from above, means from the application layer, so wait for a system call to occur from the application layer. So what call will be called by the application layer? So application layer, what it's going to do is it is going to send the data. It is going to send the data. Since the channel is RDT, that is in the transport layer protocol, we have TCP we are going to use. So since it is RDT, so send the data which is said to be reliable. Okay, which is going to receive from the application layer. So after receiving the data from the application layer, so now what we have to do, we have to make a packet, make underscore packet data, whatever the data you're going to receive from the application layer. So you have to create a packet or you have to make a packet, and that is defined as the packet here. Okay, and that packet you have to send through the channel. You have to send through the channel. Okay, so and then now at the receiver side, wait for the call from below. I already said that at the sender side, the data will be received from the upper layers. Means the communication will be from upper layer to lower layer. Where at the receiver side, the data flow will be from lower layer to upper layer. So that's why at the receiver side, we'll start the communication. Wait for call from the below. So we'll wait for call from the below. So what event has been occurred? The RDT receive means receive the packet. Okay, after receiving the packet, so what action will be taken place? So extract the data from the packet. So what you have to do? So the packet contains so many headers along with the data, the checksum with the data. So you have to extract the actual data that has to be delivered to the application layer. So extract the data from the packet, and deliver underscore data indicates deliver the data whatever you have extracted to the application layer. Okay, what is reliable data transfer 1.0? What it says is, so here there's a communication happening through the reliable channel. Okay, where there is no bit errors, where there is no loss of packets. And here we are going to use only two states. One represents the sender, other represents the receiver. Okay, so this is how it's going to create the packet and send. This is how it is going to receive the packet, extract the data from the packet and deliver the data to the application layer. Okay, this is RDT 1.0. Next, channel with bit errors. The channel with bit errors. So next principle is RDT 2.0. In RDT 1.0, what it says is, so there is a reliable data transfer through the reliable channel. But in RDT 2.0, what it says is the channel with the bit errors. Okay. So how do humans recover from the errors during conversation? So during conversation, how the humans they're going to recover from errors during conversation. Okay. Now let us think. Two people they are communicating with each other. The first person he started. Hi, hello, how are you? Then the second person, you need to give some acknowledgement. Yeah, I'm fine or I'm okay. You need to send some reply. Okay. And then suppose if he doesn't reply, if the second person, if he doesn't reply, then it indicates that there is some issue at the receiver side or there is some issue at the other side. Okay. This is during conversation. He need to reply something. I'm okay or I'm not okay, I'm not feeling well, so like that. Usually the conversation, while doing the conversation, so even the other person he should reply. Suppose if there is no any reply, either there may be a network issue or there may be a problem with respect to phone, so like that. Okay, so how do human recover from the errors during conversation? So what he is going to do, he is going to switch off the phone, he is going to turn off the phone and again he is going to redo the call. So in the same way it happens with respect to bit errors. So we'll see that. We'll see now. So what happens if RDT 2.0 means this principle with bit errors we are going to see now. Okay, so that's how if there is any problem with respect to the conversation, so usually what he's going to do, he's going to ask the second person again. If he doesn't reply, then he thinks that there may be some error. Okay, that's how in even in the communication, while doing communication also, underlying channel may flip bits in the packet. Okay, so underlying channel in the sense, so through which channel you're going to send or receive the packet. So usually the bit errors may occur there. It may flip in the sense 0 may be represented as 1, 1 may be represented as 0. Whatever the data you're going to send, so it will be in the form of zeros and ones. It will be in the form of zeros and ones. So that's why there may be flipping of data of 1 by 0. There may be modification in the data. 1 as 0 or 0 or 1. There may be changes in the data. So due to this, the errors is going to occur. So how we can detect the error? So we can detect the error with the help of the checksum. The checksum is 1. The checksum is nothing but a error detection and correction technique, which will be helpful for recovering the data, recovering the actual data. So how to recover from the error? So by receiving the acknowledgement, if the receiver explicitly tells sender that the packet received is okay, or if the packet received had error, then the sender will come to know that, oh, that's fine. If packet is received okay, then the positive acknowledgement will be received by the receiver. If if there is no any error at the receiver side, so he is going to receive the packet, then the receiver is going to send a positive acknowledgement to the sender indicating that, so explicitly he tells that, so the packet whatever I have received, so it is error free. Suppose if there is any error, suppose if the checksum it calculates the data that has been sent. So with the help of the checksum, if it finds some error, some bits is missing or some bits has been flipped, means once means modified, or some bits has been lost, then it's going to send a negative acknowledgement to the sender. So at that time, what the sender is going to do, how we can recover the error is, he is going to retransmit the packet on the receipt of negative acknowledgement. Okay, so what it's going to do, the sender is going to retransmit the packet on the receipt of negative acknowledgement. So this is how the errors can be recovered by doing the retransmission. Okay, that's what we have discussed. If two people they are communicating with each other, one people speaks hi hello, then the other person he need to send means he need to speak with an acknowledgement, hi, even I am fine here. Then the other person who thinks that, oh, since there is a positive conversation, he thinks that the communication is fine. Suppose at the other side, if the message hi hello, if he says and and if it is garbled, or if it is there is some noise in whatever the data, whatever the words that he has spoken, then it indicates a negative acknowledgement. There is some issue with the network. So again we need to speak, again we need to connect a call. So like that they're going to do the another communication. Okay. So how this bit errors can be detected with the help of checksum, how it can be corrected, that is with respect to the positive and negative acknowledgement. Okay, so next we'll move on to the other principle, that is a new mechanism. See, step by step we'll be adding mechanisms to the reliable data transfer protocol, so that the reliability has to be achieved while doing the communication. Okay, new mechanism in RDT 2.0 beyond RDT 1.0. So in 1.0, there was no error. Okay, it is said to be error free because it's a reliable channel. But here in 2.0, the error detection will be done, and a receiver is going to send a feedback with the control messages, so which contains the acknowledgement or negative acknowledgement will be transmitted from receiver to the sender. Okay, so error detection and the receiver feedback will be provided. Okay, this retransmission will be done from sender to the receiver. So this one we are going to call it as the automatic repeat request. Automatic repeat request, where this automatic repeat request, it is having three capabilities. One, the error detection will be done, and then after identifying the error, so it's going to send a feedback whether it is a positive or a negative. And the third thing, so if it is a negative feedback, then the receiver is going to do the retransmission. Then the receiver is going to do the retransmission. And we can call the RDT 2.0 as stop and wait protocol. So why it is called as stop and wait protocol? Why it is called as stop and wait protocol? In the sense, so first what it's going to do, first the sender is going to send a message. Until it receives the acknowledgement, it will stop sending the message from the sender side. Okay, so and then so it is going to wait for the acknowledgement. So after receiving the acknowledgement, it will go for the next transmission. Okay, understood all of you? The RDT 2.0, it is called as stop and wait protocol. In the sense, stop in the sense, first send a message, stop the next transmission, and wait to get the acknowledgement from the receiver side. If the sender get the acknowledgement, then again you have to start with the next transmission. So that's why it is called as stop and wait. Stop for the next transmission at the receiver side, wait for the acknowledgement from the receiver side. Okay, so that's why RDT 2.0. So where here we are going to implement ARQ, that is automatic repeat request, error detection, receiver feedback, receiver transmission. Three capabilities will be executed with the help of ARQ protocol. And it is also called as stop and wait, means stop the next transmission at the sender side and then wait for the acknowledgement from the receiver side. So that's why RDT 2.0, so it is said to be the stop and wait protocol with the implementation of the ARQ, automatic repeat request protocol, which will do error detection, receiver feedback, as well as the retransmission if it is a negative acknowledgement. So here is how here is how the communication that is happening between the sender and the receiver with the bit error is represented with the help of finite state machine for the better understanding of the user. So here it is represented using the finite state machine. Okay, so here so here there is two states at the sender side and one state at the receiver side. So we'll see each and every state and we'll discuss each and every state. So in the first state, wait for call from above means it is waiting for data that has to be sent from the application layer. Okay, reliable data transfers has sent the data from the application layer. Now, whatever the data that has been received, so for that data, the checksum will be attached in order to identify or detect the error, and you're going to create a packet, and that packet will be sent through the unreliable data transfer channel. Okay. So, at the sender side, suppose if it receives the negative acknowledgement, RDT receive packet, and it is a negative acknowledgement. So it is going to receive the packet from the RCV means from the receiver it is going to receive the packet. So RDT receive the packet and it is a negative acknowledgement. So what you have to do, you have to resend the packet again. Suppose if this event occurs, so this is the action that has to be taken place. Okay, if this is the event that has been occurred, so this is the action that has to be taken place. Okay, and then so it is going to send a message. It's going to send a message to the sender to retransmit the data. So UDT send the same packet to the receiver. Suppose if it receives the packet and if it receives the positive acknowledgement, ACK, if it is a is acknowledgement. So ACK indicates positive acknowledgement, NAK indicates negative acknowledgement. If it is a positive acknowledgement, whatever the packet that you have received, if it is a positive acknowledgement, then don't do nothing. So it can be represented by L. L indicates don't do nothing, or you can also represent it by you can also represent it by L, or you can also represent it like this. Okay, the power symbol. Okay. So what this indicates, so since it has received the positive acknowledgement, so it indicates no action has to be taken place. You can start with the next transmission. Okay. So here at the receiver side, so at the receiver side what happens? Wait for the call from below. So from below, it is going to receive the packet. Suppose if the receiver packet is said to be corrupted. RDT receive, so receive the packet And if it is said to be corrupted, corrupt indicates if the received packet is corrupted. Okay, then send a negative acknowledgement. UDT send NAK means send a negative acknowledgement to the sender. Suppose if it is going to receive the packet and it is said to be non-corrupted, it is a not corrupted packet. Whatever the packet, the received packet that you are going to receive from the below layer, and if it is said to be a non-corrupted packet, then extract the data from the received packet, because the received packet, it contains the headers along with the data and then the checksum. So extract the data from the received packet and deliver the data to the application layer. Deliver underscore data indicates deliver the data to the application layer, and UDT send the acknowledgement. So acknowledgement in the sense the positive acknowledgement. So if it receives, if the sender receives a positive acknowledgement, it doesn't do anything. If the sender receives the negative acknowledgement, it is going to do the retransmission. Okay, so that is RDT 2.0. So RDT 2.0 with no errors. So it is same as the above, but here suppose if there is no errors, so what it's going to do, it doesn't send any negative acknowledgement, only the positive acknowledgement will be sent. Wait for the call from above. So it's going to receive the packet. Packet will be sent, which contains the data and the checksum. And then at the receiver side is going to receive the packet. Okay. So just a transmission. Either it has to receive the positive or negative acknowledgement. Since it is error free, it is not corrupted, it's going to send the positive acknowledgement. So it indicates no error. Okay, so it here now this explains the error scenario. You can see here. So wait for call from below above. So receive the data and then along with the data add the checksum. So now create the packet and send it to the receiver. So at the receiver it is going to wait for call from below. Okay, now the packet will be sent. But whatever the packet that has been received, the packet is received but it is corrupted. So what we have to do, we have to send a negative acknowledgement. Negative acknowledgement will be prepared and that will be sent to the sender. Okay. So now what it's going to do, it has received the sender has received the packet, but it is a negative acknowledgement. Okay, it's going to generate a packet in order to do the retransmission. Okay, so retransmission of the packet will be done. So this is the scenario where there is said to be error, but whatever the packet now it has received, so it is said to be error free. So now it's going to send the positive acknowledgement. Okay, so now this state it will be waiting for the next transmission. Okay, so RDT 2.0 has a fatal flaw. What happens if acknowledgement or negative acknowledgement is corrupted? Okay, see here, you have the sender has sent the data and it is also reached at the receiver. But while sending the acknowledgement back to the sender, the acknowledgement or negative acknowledgement is corrupted. Sender doesn't know what happened at the receiver. It can't just retransmit the possible duplicate. Okay, so how to handle these duplicates? Okay, suppose sender retransmit the current packet. If the acknowledgement or negative acknowledgement is corrupted, so it is better to add the sequence number. Okay, it is going to send. Okay, sender adds a sequence number to each packet. See, you're going to retransmit the packet, you're going to send a new packet, but how the receiver is going to detect whether it is a retransmitted packet or a new packet that you have sent? So that's why we need a sequence number. Okay, so the receiver discards, it doesn't deliver up or duplicate packet. So suppose if you specify the sequence number, to the packet whatever you're going to send. At the receiver, it is able to identify. Suppose if you have resend the packet called as 0. At the receiver end, it is going to check whether the packet with sequence number 0 is existing. If it is existing, it is going to drop there itself. It won't accept that packet since the sequence number is same and already the packet is existing at the receiver side. So since it is a duplicate packet, it is going to discard that packet. Okay, this is one of the flaw in case of second principle RDT 2.0. So RDT 2.0 has a fatal flaw. So since the packets will be retransmitted if there is any negative acknowledgement. Suppose if the packets you're going to send, it is retransmitted packet or a new packet, it won't be knowing by the receiver. So that's why if you add a sequence number, so with the help of the sequence number, the receiver side, it is able to identify that already this packet is existing and this packet is a duplicate packet that has been sent by the sender. So no need of accepting this. So just we can discard there itself. Okay. So this is how a fatal flaw we can able to identify. Okay, so this is said to be a stop and wait protocol. Sender sends one packet and then waits for the receiver to respond. Okay, sender sends one packet and stop there itself and wait for the receiver to get the response from the receiver. So that's why this RDT 2.0 it is called as stop and wait protocol. Okay, so these are the two principles we have discussed. So tomorrow we'll discuss about RDT 2.1. So here the sequence number we have identified is 0 and 1. 0 and 1. So 0 indicates old packet, 1 indicates the new packet. So like that 0, 1, 0, 1. Okay. So RDT 1.0, RDT 2.0 we have discussed till now. So the difference between RDT 1.0 and RDT 2.0 is, so in RDT 1.0, the communication that is happening between the two entities where the channel is said to be reliable channel. But RDT 2.0 is the communication happening between two entities where it may contain bit errors. Where it may contain bit errors. And how this bit errors can be handled with the help of checksum. How the sender is able to know whether the packet has reached or not with the help of the acknowledgement. How the sender is able to know whether the packet is reached or the packet is lost or the packet is corrupted. If packet is reached, the receiver sends positive acknowledgement. If packet is corrupted, then the receiver is going to send a negative acknowledgement. So we have seen the corruption free with corruption or without corruption, both the scenarios here. So both the scenarios we have discussed. So this is the error scenario and this is the error free scenario. Okay. And this is just the general description about the RDT 2.0 with the FSM specification and then positive and negative acknowledgement. So how this human errors during the conversation can be overcome with the help of positive and negative acknowledgement. Okay, then this is RDT 1.0 and a simple introduction about the finite state machine and then how the reliable data transfer is going to get started with a small function called as RDT send, UDT send, RDT receive and deliver the data. Okay. So next version or the next principle that is with respect to RDT 2.1. So we are going to discuss in the next class. Thank you.
Thank you, ma'am.
Thank you.